297.09. We'll just keep that at 1,297 people. And we want to make sure we're labeling. Now, obviously, I keep forgetting to put it back to here. So go ahead and copy that down. Obviously, when we plug this stuff in, it doesn't come out as very accurate. There are a lot more people than 1,000 that are infected, but that's not what this is about. It was just an example. That would probably be accurate for one town, maybe. But yeah, all you're doing is plugging in those X values into a calculator, and it's really easy to do. Okay, so now we're going to talk about compound interest, which is really good for when we're talking about loans. Everyone's going to buy a car. Some people are going to buy a house. If you go to college, you're going to have to pay off school loans. So compound interest is very relevant, and it's really important you understand how it works. I'm buying a house right now. I have to talk about compound interest and all that stuff with my realtor and everything. So it is very relevant. So compound interest is interest compounded on an original investment, and then that interest is added to the original amount. So these equations do that for us. It's a plug and chug yet again. All right, so here's our equations. There are two types of compounding interest. There's ones where we have it continuous, it's just always compounding, or we have where we have a certain amount of compounding periods in a year. So with the compounding periods in a year, that's this one here. Here's our equation. It's going to be P times the quantity 1 plus R over N to the NT. And then if we have continuous compounding, it'll be P E to the R T. That one's PERT. It should be very easy to remember, especially if you watch Parks and Rec. All right. So here are, let me adjust the camera. Okay. Nope. There. Okay, so let's just talk about what each of these things are. It'll tell you if it's compounding continuously or if they're compounding periods, so you don't have to worry about knowing which one. So R is going to be the interest rate as a decimal. Okay. N is the number of periods in a year. T is going to be our number of years. If you need to, you can pause. You might have to pause this if you're having a hard time reading. Hopefully you can see that okay. It's definitely big enough. It just might be smushed together. P is the principal or original amount. And then A is the account balance. Which is awesome. Okay. So where are my papers? Here they are. Gotta change it out really fast. Okay, so we're gonna do two examples together and then we're gonna be done. There's that. Let me erase. Don't judge me. I'm using an old sock that doesn't have a pair. Honestly, you should be applauding me because I'm reusing my clothes. They're clean, just don't have friends. Okay, slot this guy in here. Okay. All right, so we're going to do 2 examples here. All right. Here we go. If you deposit $6,500 into an account paying 8% annual interest compounded monthly, how much money will be in the account after 7 years? All right, so it tells us right away, well, not right away, but it tells us that we're compounded monthly, which means that we're going to use the equation A equals P times 1 plus R over N to the NT. We're going to go ahead and say, oh, that's blurry. Here we go. We're going to find what P, R, N, and T are so that we can find our final balance A. If we're depositing money into the account, that's going to be our initial amount because it's our deposit amount. That'll be $6,500. We have 8% annual interest, so what we're going to do is we're going to take this 8 and do 8 divided by 100, and that's going to give us 0.08. So that is our rate as a decimal. You see that? Yep, 0.08. N is the number of compounding periods in a year, and if we're compounded monthly, there are 12 months in a year, so we have 12 compounding periods. And then T is our time, so that's going to be 7 years, so T is 7. So then we just plug all this stuff in to get A equals 6,500 times 1 plus R over N to the N times T. So 6,500 times 1 plus 0.08 divided by 12 times 12 times 7 to the 12 times 7. So we'll plug that into our handy calculator right here. So we've got 6,500 times 1 plus 0.08 divided by 12. And then we have to put parentheses around 12 times 7, otherwise it won't work. We end up having 11,358.24, and we're going to round to the nearest cent, which is hundredth, 2 decimal places. We want to put dollar signs on that because we're talking about money. How do I get back? Here we go. All right, so we're going to round to the cent. So we have $11,358.24 after 7 years. All right, one more example. Really, you should be able to do this one on your own, but we'll talk about it. So Shing puts $800 into an account to use for school expenses. The account earns 14% interest compounded continuously. How much will be in the account after 5 years? So because we're compounding continuously, we're going to use the equation A equals PE to the RT, PERT. So we need P. E is a constant, we don't need that. R and T. P, our principal amount. So Shing puts $800 into the account. It earns 14% interest, so that means it earns 0.14 as a decimal. And we want to know after 5 years how much it's worth. So we'll plug all that in. We get A equals 800, not 500, 800 times E. It's an E there. Make it a little clearer. E. Oh, that was awesome.